Today we are going to start a unit on a topic called power series. Our power series is a series that has an x in it but goes on to infinity. So it kind of looks like a Taylor polynomial, but it has more to it than that. At the top of the page, you can see how we worked out Taylor polynomials, Maclaurin polynomials specifically, for e to the x. And this is similar to the one we just finished doing as practice. Now that we know about series, we're going to kind of do a marriage between Taylor polynomials and series, and they're called power series. Now, not all power series happen to be Taylor polynomials. As a matter of fact, we're going to do a whole lesson on Taylor series tomorrow. But this is a very, very big unit on the AP exam. There are almost always is a question about a Taylor series somewhere, and a Taylor series is a type of power series. Okay. Now, this is a specific infinite series called a power series. What makes this different from what we just finished learning about is not only in your summation do you have n's, you also have x's. Okay? All the ones that we analyzed for convergence and divergence were just n's. Now we're going to have them with x's in them. So the power series for e to the x goes out forever. It doesn't. A fourth degree Taylor polynomial stops at the fourth derivative, but a power series for e to the x goes on to infinity. Okay? Now what's interesting, this power series, this one here, converges for every x. And so actually that is how the calculator calculates e to the x. It uses the power series for e to the x to do it. Okay? Because it can do that. How does a calculator do that? Well, a calculator can easily square, add, subtract, multiply, and divide. It doesn't have a table of values in there to find e to the 2.5. It uses the power series to do it. Okay? So the box in the middle is very important. And this is on the page that I gave you that went into your flip book. If x is a variable, then an infinite series of the form sum of n equals 0 to infinity of a sub n x to the n. Now up till now, we've just seen, let me move my pen, we've just seen a sub n right there. Now we have an x to the n as well. So that means that it's written out as your a's progress, your x powers go up. This is called a power series centered at 0. Please underline centered at 0. The one below it is very similar, except it has a minus c in there. And this one is centered at x equals c. Okay? You will be asked to find the center on every one of these power series. So, if you don't see the x in a parentheses with something else, it's centered at 0. If you do see it in a parentheses with something else, if it says x minus c, it's centered at positive c. Okay? That's basically the point of tangency when you're comparing it to a Taylor polynomial. All right? Now, one thing you need to know for this process, 0 to the 0 power is an indeterminate like 0 over infinity, but for this that we are doing, we're defining it to be 1. Okay? So anytime you have a situation of 0 to the 0 power, it's 1. Just like 0 factorial is 1. Okay? Now, a couple of things you need to know. This is a power series. It's basically an extended polynomial. Missing terms have a coefficient of 0. The power for each term must be a whole number. You can't have negative exponents. Okay? So what I want to do is look at these first three problems, and it says to expand the following series, which we're actually not going to do, so you can mark that out. We are going to determine if it's a power series, and if so, where is it centered? If I plug in 0 for the exponent of x, and then 1, and then 2, and then 3, will all of the x's exponents be positive? Yes. So yes, this is a power series because the exponents are positive. Now, where is it centered based on what was written in the box? Is it 0 or is it something else? Okay, look where the x is. It's where the x is. Notice that when it's centered as something else, it's x minus a number. You see x minus a number? No. So this one is centered at 0. On the next one, if I plug in 0, then 1, then 2, then 3, the exponents will be positive, yes? So this is another yes, it is a power series. This time it is not centered at 0 though. What is it centered at? It is at positive 1. Because notice the formula says x minus c, but it's centered at positive c. So this one is centered at 1. Now the next one, actually writing out a few terms would not be a bad idea for this one. If I plug in 0, that would be 0 over x to the 0 plus 1 over x to the first plus 2 over x squared plus dot dot dot. Okay? Are those exponents on x positive? Not really. Just because they're on the bottom they're positive, but in reality they're negative, aren't they? So this one is a no, it is not a power series because of the negative exponents. So, not only do you have to be able to recognize a power series, you have to be able to find its domain. That is the big focus of today's lesson, is finding the domain of a power series. Now, what does it look like? All of them really look like this. If c is 0, do you see that that would just be a sub n x to the n power? If c was 0? Do you see? Yeah. So, that fits the mold for everything. The domain is the set of all x's for which the power series converges. So we're going to take what we learned last unit on convergence and divergence, and we're going to determine where these things converge. Now that we've introduced a second variable, it's going to kind of mess with the way this thing converges or diverges, because sometimes when you plug in, say, 1 for x, it'll converge, but if you plug in 2 for x, it's going to diverge. You've got to find out where it converges. It's very, very important that you do. Okay? So, in the first example above, if you put 1 in for x, if you change the x to a 1 and then wrote out the series, you would get this as your nth term. And that one, by the ratio test, converges. Okay? But if you take the second problem and you plug in 1 for the x, you're going to get an alternating series which is divergent. So it varies from problem to problem. And what we're going to learn today is how to find out where it converges and which points it is. Which numbers work, which ones don't. Graphs are usually easy. You just look at the graph, oh, the domain is from here to here. This one is a little bit more involved. So, go to the back of this page, please. All right. Now, there are some terms that we need to be familiar with. We already talked about one of them. C, write this at the top for me. C is the center. And that is the number that's in the problem with x. And it always converges at the center. So you are guaranteed it's going to converge at C every time. Always. But sometimes that'll be the only point. So that is the scenario in this box over here. The only point of convergence is C, and that's possible. Okay? The next possibility is that it converges at the center and then at some sort of a distance out from that point. And that is called the interval of convergence. Okay? The distance out is r, which is the radius. Capital R was the radius. Your problems are going to ask you to find capital R and the interval of convergence. The interval of convergence is basically the distance out each direction from C. So it's parentheses C minus R, comma, C plus R, like written like a domain. You go from the center to the left R units, and then you go right R units. What we're going to learn how to do first is to find R. How do you find the radius of convergence? Okay? So, this first example right here is a little bit confusing because it's already done all the work for you. So I'm going to jump down and walk you through how to do this in a different problem. Okay? Oh, I forgot to talk about this one. The third possibility. It's possible that it converges for everything. No matter what you plug in for x, it's going to converge all the time. Okay? And this situation, this one right here is when r is equal to infinity. This situation here is when r equals 0. There is no radius of convergence. And the radius of convergence here means it's going out forever in both directions. Okay? I'll show you samples of these and what they look like. So, number 5 asks you to find the radius of convergence for this series right there, okay? Now, I've noticed that in these notes that he tends to write out the series, and I don't think that's very helpful. I think it's better just to look at the term itself, okay? Now, first of all, tell me, what is C? What is C for this problem? Based on what you see right there next to my thumb.
0.
C is 0. Do you agree with that statement? Okay? So it definitely converges at 0. If x is 0, it's going to converge, because it's going to be a string of zeros. What kind of series is that? If that x was a 1, what test would you use to test for convergence on this series?
Ratio.
You could use the ratio test. Yes, you could. And that's a great one to use. Why would you choose ratio test? Because of the factorial. Very good. Okay? So, let's test the, we're going to test for convergence. And many times we use the ratio test. We're going to use a ratio test for this one. That is a common one to use. So we're going to do the limit as n approaches infinity, absolute value, remember. How do you do the ratio test? You tell me.
You do n plus 1 for all the n.
Right.
And the reciprocal of the original.
So -1 to the n plus 2, x to the n plus 1, all over n plus 1 factorial. So every power goes up by 1. Every n goes up by 1. And then that is over the original problem. So that's -1 to the n plus 1, x to the n over n factorial. Now, what I'm going to do is I'm going to go ahead and flip it up here. N factorial over -1 to the n plus 1, x to the n. Now, how does this clean up? Look at the n's.
The x, you can cancel the n factorial.
The n factorial. And what does it leave down here? N plus 1. Very good. What about the -1 powers? They would cancel, but leave what where? -1 on top. So there's a -1 up here. Do the x's simplify as well?
Yeah.
Yes. So what would there be? And
X on top.
x on top. So now I'm down to the limit as n approaches infinity of -1x over n plus 1. Okay? Now, this is where it gets a little weird. Because every other time that we've done limits at this point, all that we've had left in the absolute value are n's. But now we have n's and x's. Okay? So for just a minute, we ignore the x. A good way to ignore it is just to pretend like it's a 1 for just a second. What is the limit of that thing going to be if it's just -1 over n plus 1?
0.
It's -1 over infinity, which is 0. Okay? So, this limit, no matter what x is going to be 0, isn't it? No matter what x is. This is 0. We're done. If x was 2, it'd be 2 times 0. If x was 5, it was 5 times 0. Agreed? Yes.
Just like hypothetically, if x was infinity, what would happen?
X would never be infinity, not in these instances. Okay, that's a good question though. The limit is 0. So, if the limit is 0, does it converge or diverge? It converges because on the ratio test, if you get an answer that's less than 1, it's an automatic convergence, isn't it? So, therefore, this converges for all x's. And that tells me that the radius of convergence is what, based in the box? Look in the box. When if it converges for everything, what's r equal to? Infinity. The radius of convergence is infinity. Yes, ma'am.
Okay, so did we know C was 0 because there's no x minus C?
Yes.
So if it can only ever be 1 or 0. You're seeking.
Well, it could be x minus 5, or it could be x plus 2. It's just the number in the parentheses with x is what it converges to. X minus
Because like on the front, it was x minus 1 to the n, and we said c equals 1.
Because it was a 1 in the parentheses with the x.
So if it was x minus 5, it would be 5.
5. It would be
If
5.
it was x plus 5, it would
Be
be
negative 5. Yes, ma'am. You got it. You've got it. Any other questions before we move on? Are we good on the radius? Okay? Now, let's try another one. Look at number 6. Now, I wrote this actually a page early, but that's okay. Find the radius and the interval of convergence for this. All right? So, what is C? C is 2 this time. Do you see that? So C is 2. Last time C really didn't mean much because the radius was infinity. When the radius is not infinity, that's when C comes into play. Okay? So the question is, looking at just the formula, if you were going to test that, what kind of series is that? It is geometric. Do you all see that? Mm-hmm. It is a number times something to the n power. A1 r to the n. Okay? How do we test geometric series?
You find the r
You find the r, and what does r have to be to converge?
less than 1.
It has to be between -1 and 1, exactly. So let's write this down just for reminder's sake. You don't have to write this out when you do the problems, it's just while we're learning. This is geometric, so the absolute value of r has to be less than 1 to converge. Agreed? You put the r in absolute value, it has to be less than 1 to converge. All right, so what in my problem is r? It is x minus 2. Do y'all see that? So we're going to change r to x minus 2 is less than 1. And now we have an algebra problem. Okay? My first period class was a little bit skittish on how to work this problem because I'm not really sure how you guys were taught this. Okay? When it's stuck in absolute value bars, you can't do anything. You can't move the 2. So does anybody remember how to fix it, how to get it out of absolute value?
Yeah.
Say what you said again? The 2 becomes, it doesn't work that way with adding, unfortunately.
Don't you just move the whole thing?
What do you mean move?
Just move the whole bar, like the x minus 2, move the whole thing to the other side.
No, you can't do that. You still have the problem. You need to get it out of there. Moving it doesn't help.
Can you do e?
E doesn't help.
Ln?
It actually comes back to something the DJ said just a minute ago. What did r have to be between? -1 and 1. This right here means that it is between -1 and 1. Let me show you. Let's say you had a number line. Okay, watch this. Here's 1. Okay, give me a number. Forget about the x minus 2 for a minute. Give me a number you know is going to be, that r would be true.
0.
R would be 0. 0 works, right? Does anything between 0 and 1 work?
0.5.
0.5 works? 0.6, 0.1, they all work, don't they? Do any negative numbers work? I beg to differ. -1/2. Think about it. If I put -1/2 in there and took its absolute value, would it be less than 1? Yes. What about -3/4? Everything down to what?
-1.
-1. -1 does not work, so I'm going to put a parentheses there. And 1 does not work either. So look what I'm putting in there. Isn't that between -1 and 1? Yeah. Okay, so watch. Here's what we do. Whenever you see this, we take off the bars, we put it less than 1 and greater than -1, just like that. That's the magic way to take absolute value bars off of less than problems. Just like that. That is called a compound inequality. It's basically 2 problems in 1. There's one problem. Look at the screen if you're not looking up right now. That's one problem right there. And there's the other problem right there. Okay? Now, what's really cool about this is you can work 2 problems at once. Okay? I purposely like to cover up one side when I'm doing this. Look at what you see there. What is the mathematical thing I need to do to solve for x?
Move 2 to the other side.
Move 2 to the other side by what operation? Adding. So I need to add 2. What about this way? Is adding 2 going to get the x by itself this way? Yeah, so we're going to do it here, here, and here. That's legal. That's legal. So this side is going to say 1 is less than x is less than 3. And that is my interval of convergence. So my interval of convergence is 1 to 3 with parentheses. Now, the big question is, what is R? R takes a little thinking. Okay? What is C again? C is 2, right? Didn't we say C was 2 at the beginning? How far is it from the C in the center to one end of the interval?
1.
1 unit. How about the other way?
1.
1 unit. So R is 1. That's the answer. The interval of convergence and R. Question?
Can you explain why R is 1 again?
Okay. So if you graphed it, my interval of convergence is from 1 to 3, and my center is at 2. Okay? How far is it that way and that way? 1 unit. That's why R is 1. That's what R is defined to be. R this way, R that way. Okay? Questions? All right, let's go ahead and do number 7. It says for the series that's given, write the first few terms. Let's not worry about writing the first few terms down. Find the interval and the radius of convergence. Okay, I'll always start with C. What is C for this problem? What do you think?
1/5.
Is C 0?
1/5.
Okay, it has to be in a parentheses with the x, added or subtracted.
C is 0.
So in this case, it's 0. There's nothing. So C is 0. What test could we use on this one? Not root when it's more than just an n. Could we do ratio again? Yes, ratio is a good one to do. So ratio test, we're going to do limit as n approaches infinity, absolute value, x over 5 to what power? What power? If it's 2n minus 1 now, and I'm going to raise it 1, just 2n. Very good. So this is 2n over x over 5 to the 2n minus 1. So, what is that going to clean up to be? Well, okay, which one's bigger? Top or bottom?
Top.
Top is bigger by how many?
1.
1. So when you cancel, there will be 1 left on top. So it would just be a single x over 5. Agreed? Do we have any n's left? No. So there's no limit to be found with the n approaching infinity. However, what has to be true about this absolute value in order for it to converge? Is it less than 1 or greater than 1? Look in your flip chart if you don't remember. This is ratio test. Are you sure? Let's check. Ratio test says converges if the limit is less than 1. So what we do is we set this limit less than 1. So basically the limit part is no longer needed because there are no n's, right? So we can kind of like lightly X that out. So here's our equation, just like we had the one that you can't see up here. So we're going to do to this one what we did to this one. And it's still the same number, so we're going to do it the same way. So it's going to be no absolute value bars over x minus 5, less than 1, just recopy that part, and then greater than negative 1. We sandwich it in between a negative 1 and a positive 1. Okay? Cover up one of the inequalities. What do we mathematically do to get x by itself? Multiply by 5. So I'm going to put the whole thing in parentheses and multiply by 5. So we're going to get negative 5 is less than x is less than 5. Okay? That is my interval of convergence. Negative 5 to 5. Okay? Now, what is R? During my little break, we've come up with a formula to figure out R very quickly. And it is to take the endpoints of the interval, subtract them, and divide by 2. So we take the two endpoints, 5 minus -5, divide by 2, and we get 10 over 2, which is 5. And there's your radius. Okay? We're going to call it O's there, because Olu came up with it. And now he's for posterity's sake, on video.
So that means next year you're gonna teach it as Ovi's theorem?
Yes.
Oh,
All right.
students.
Any questions about what I did mathematically? Okay? Now, we have done basically 3/4 of what we have to do for the problems today. We know how to find C, we know how to find the interval, we know how to find R. The only thing we have not done yet is we have not tested to see if either one of the endpoints are also a point where there would be convergency. Okay? So we're assuming that neither one of these work in the problem as of right now. But what we're going to do now is we're going to have to test our endpoints of our interval to see which one converges and which one diverges. Usually the test is a very simple one. You just plug in the number, write out the series for a couple terms, and look what it does. It's either going to obviously converge or obviously diverge. Okay? And what that does, if you look in this box, it looks a little complicated. Basically, you remember that with domains and ranges, whoops, I'm pointing to something you can't see. With domains and ranges, sometimes it's parentheses and sometimes it's brackets, right? Bracket means it converges at that number. Parentheses means it diverges at that number, okay? So as we test our points, we may end up having to change one or both of these to brackets, okay? Any questions? So the next few problems we're going to do are the same procedure, but we're going to just add another step, okay? So turn the page. Go to the back. Number 8. We're going to do 2 of these. Number 8 says, write out the first few terms and find the interval of convergence. You don't need to write out the first few terms. Mark that out. All right. So here is our power series. What is C for this problem? Does everybody understand why C is 0?
Isn't it basically like you do x minus c, but the c is 0?
Exactly.
So it's x minus nothing because there's no minus.
Exactly. You're exactly right. There is nothing subtracted from here. It's x minus 0. That's exactly correct. All right. So look at this problem. Does that fit the mold of any kind of power series that you've seen before? Yeah. Can we do ratio test to this one? Yeah, let's do ratio test to this one. It works pretty well. So we're going to do ratio test. Limit as n approaches infinity of x to the n plus 1 over n plus 2, right? Over x to the n over n plus 1. We're going to flip that up. We're going to get n plus 1 over x to the n, close my absolute values. Same thing we've been doing. Okay, what do you see that simplifies?
X to the n plus 1 and
X to the n plus 1 and x to the n. So this becomes what where?
x on top.
X on top. Okay. Now, can I simplify the 1 and 2, n plus 1, n plus 2?
Yeah.
No.
If that was a 4 and that was a 5, could you reduce that? No. You can't. So basically, the n's have to stay there. So what we're going to write now is we're going to write the limit as n approaches infinity of, now, the x that's left I want to leave off to the side. So I have n plus 1 over n plus 2 and an x off to the side. Because if you keep the n's together, it makes it easier to evaluate that specific limit. Okay, this is the first time, if I remember correctly, that we're left with both n's and x's in here. Okay, except for the one time it was an automatic 0. But look at this. What you're going to do now, you're doing the limit part first. Pretend like the x is a 1 and basically cover it up. What is the limit of that quotient?
1.
It's 1. How do you know?
Infinity over infinity.
Infinity over infinity, and then you go into L'Hopital's rule and it's 1. Do you agree with that statement? So basically, this part is becoming a 1. So we have just an x left in there because the x is not affected by the limit. Okay? Once again, absolute value of the ratio test has to be less than 1 in order to converge. So now, how do we write the problem without the absolute values? -1, less than x, less than 1. And there's no math to be done. It's finished. That's our interval of convergence. So interval is, oops, I didn't mean to do that. I'm going to have to erase that because I don't know whether it's bracket or parentheses. I kind of jumped the gun.
Wait, I have a question.
Yes.
How do you know that x is less than 1?
Okay. According to ratio test, whatever you end up with in the absolute value bars has to be less than 1 in order for it to converge. All that was left in the absolute value bars was the x.
Oh, because it's interval convergence. So.
Right,
Oh, okay.
right. So it's going to be -1, comma 1, but no outside things yet because I don't know whether they're brackets or parentheses. Okay? Now, when it comes to testing them, we're going to come out to the side and we're going to actually plug in the number for x that we're talking about. And we're going to take a look at the pattern. This is going to be now -1 to the n over n plus 1, starting at 1. I didn't write the series symbol down, but we're going to just in our heads do that. So if you start at 1, the top will be -1. The bottom will be what? 2. Now, the top makes it what kind of series? Alternating, okay? So I really don't need to worry about the top anymore. I just know that, oh, my first term was negative, so guess what sign my next term is? It's positive. It's going to be 1. Bottom's going to be 3. -1 over 4. Are you following where I'm getting all this from? Plus 1 over 5 minus ... Okay. Now, what does that thing do? Converge or diverge? Okay.
It converges.
It is an alternating series, yes? And the alternating series has to have 2 things happen. Does anybody remember what they are? Tell me.
Equals 0.
Limit is 0.
The terms decrease, so n plus 1 is less than a1.
Exactly. It has to, the limit as you approach infinity has to be 0. Is this thing, are these going to be a limit of 0 as you go out? Okay. So we can say that the limit as n approaches infinity will be 0. And are the terms decreasing? Yes. A sub n plus 1 is less than a sub n. Therefore, this one converges. Now, I am still in contact with my friend about whether or not you have to write all the alternating series tests down for this. I will let you know. I'm going to go ahead and just abbreviate. I'm going to kind of do a alternating series test is what I just did. I'm not writing it out formally. Off the side here. There we go. So that tells me -1 because it converges, gets a bracket. Okay?
Is that like on the notes?
Yes, at the bottom on the page before. Okay. Now, what about x equals +1? And that's going to be +1 to the n over n plus 1. And 1 to the n, 1 to any power is always what? 1. So this is just 1 over n plus 1, which is 1/2 plus 1/3 plus 1/4 plus 1/5. They're all positive, same thing. What series is that? That is harmonic. Therefore, it's going to do what? Harmonic. Therefore, diverges. And that's all you would really have to write. So, does 1 get a bracket or a parentheses? Parentheses. Done. Okay, so you just see how we just added one more step? Actually, kind of 2 more steps. One for the left endpoint, one for the right endpoint. Question?
So I see that we put, the bracket parentheses type thing for number 8. For the past 2 problems, 7 and 6.
We just kind of ignored that. All we did was the interval, but not the endpoints. Okay. From here forward, you always need to do the endpoints. Okay. So we kind of built it in layers. We first talked about just C, and we talked about the interval in R, and now we're talking about the endpoints. Okay. Any other questions? All right, let's do number 10, because it's kind of ugly. And we're going to use a different test, because I actually did this problem one way, and one of my students first period said, well, why don't you use a different test? And his test was easier. So we're going to do it that way. All right, what is C for number 10?
-2.
It is -2. Very good. Oh, I forgot to write down. Let's go back. Rewind. What is R for this one? It only asks for the interval, but I want to still write down what R is. It is 1. 1 minus -1 is 2. Divided by 2 is 1. So R is 1. Okay? Are we good? All right, back to 10, sorry. So this one only asks for the interval of convergence. Don't need to do that. So look at that problem. What test would work on that? That is a perfect root test problem. Do you see that?
Yeah.
Everything is to the n power. I did ratio test. Oh my gosh, it was so ugly.
Could
And-
you also do alternating series?
You could, but you'd have to write out the terms to see what's going on. I think root test is easier. So we're going to do the root test to this one. Now limit as n approaches infinity of the problem itself. Now what we're going to do is we're going to pull the n out completely from everything. So we're going to have -1 times x plus 2 over 3 in a parentheses to the n, and then outside to the 1 over n. Kind of squeeze that n in there, sorry. What's going to happen to the n's? They cancel out. Thank you very much. So now we just have, and I can drop the limit because I don't have any n's left. So I just have -1 x plus 2 over 3. Is root test the same as ratio when it comes to convergence? Is it still supposed to be less than 1?
Yes.
Let's see. I'm double checking. Convergence if limit is less than 1, so yes. Yes.
Is the 1 over n inside the absolute value?
No, it's outside.
Oh.
All right. Now, this one's a little uglier, but we can do this. Break it apart like we've done before. -1 less than -1 parentheses x plus 2 over 3 less than 1. Just take what's inside, squish it between a -1 and a 1. All right. I'm going to cover up the right-hand side. What do we do mathematically first to solve for x?
Multiply by 3.
Multiply by 3. It's going to be -3 is less than -x minus 2 is less than +3. I went ahead and distributed the -1. Now what? Add 2 to all three components here. So -1 is less than -x is less than 5. Now what?
Divide by 3.
Divide by -1. And a big red flag should be going up in your brain. Why?
Because there's no negative.
The signs change. This becomes +1 is greater than x is greater than -5. Which is kind of backwards for writing an interval. We always want the smaller number first.
Oh, you could change the signs.
So we go -5 is less than x is less than 1, and that's my interval. So interval is -5 comma 1, no outsides yet. So we're going to do -5 first. Okay, I'm going to tell you that it's much easier to plug in the -5 for x in the factored, taking the n out of everything problem. So we're going to have -5 plus 2 over 3 to the n. What does that clean up to be? What is the top? It's -1 times -3,
-3. 3.
which is +3 over 3. So this is 1 to the n. So that would be 1 plus 1 plus 1 plus 1 plus ... Converge or diverge? That's a big time diverge, right? because it's just getting bigger and bigger and bigger. Now, there's really no reason needed for that. That's kind of an obvious, it diverges. So, -5 gets a what? It gets a parentheses. X equals 1, dot, dot. So we're going to have -1, 1 plus 2 over 3 to the n. It's going to clean up to be -1 to the n. Agreed? Because that's parentheses is 3 over 3, leaving the -1. So that's going to be -1 plus 1 minus 1 plus 1, and so on. Converge or diverge?
Isn't it also?
What'd you think? -1 plus 1 minus 1 plus 1 minus 1 plus 1. It oscillates. Oscillate, remember, means it goes up and down the same amount every time. Alternating means it eventually kind of be leveling off, possibly, but an oscillate is a true up, down to the same number every time. This oscillates, and oscillating's always what? Always what? Diverges. So that means the 1 also gets a parentheses.
So if it diverges is parentheses and it converges is brackets?
Yes. Just like when you are doing domain and range, if the number is included, if it converges, the number is included, so it's a bracket. If it diverges, the number is not included, that's a parentheses. Okay, tell me what R is. It is 1 minus -5 is 6, divided by 2 is 3. And there we go. Do you have any questions? So this is power series. Writing it out, finding the interval, the C, the interval and radius of convergence. Okay.